All right, let's get started. Good evening, everyone. Welcome to Infrastructure as Code Live. For those who don't know me, my name's Sam. I'm an Azure MVP, and we're doing this as part of this year's festive tech calendar. So, Merry Christmas, everyone. I'll be here for the next hour or so, answering any questions you've got on Infrastructure as Code. So, anything you'd like to know about ARM templates, Bicep, Terraform, Pulumi, anything else, just drop a question in the chat, and I'll be more than happy to try and answer them. Might not be able to answer every single question, we'll see, but I'll certainly do my best. This is my first go at using Twitch as well, Jan, so we'll see how that goes as well, but hopefully it comes off okay. So feel free to drop any questions you've got, and we'll work our way through them. Got a few things open here in case anyone wants to look at some examples or have a play with some things. So I've got a little pet project of mine here using Terraform to actually deploy some Azure resources, and this is for an interesting project. So I don't know if anyone here has ever played Transport Tycoon. So this is a game from the 90s, I think it was, where you built transport networks and so on. And there's a multiplayer version of that, and there's an open source version of that now. And so this is a game I've been playing with a few friends and colleagues at work. And so what I've been doing is putting together some Terraform here to actually deploy the infrastructure that's actually going to run that hosted server. Seems might be a bit overkill, but it's an interesting project to play about with some things. So this current version is in Terraform. One thing I'm thinking about doing is changing that over to Pulumi as well to have more of a play with that. Pulumi is something I've been using for a little while now on the day job in terms of doing infrastructure as code using real programming languages, which is quite an interesting thing to look at. That's something we can discuss if you want to. But yeah, this is a little pet project that I've been working on that we can have a look at some examples as well. So to say, if anyone's got any questions or anything they'd like me to demo for them, just drop it in the chat and we can do that. If it's not an immediate, one thing we can probably start with is the question that comes up on nearly every conversation I have about infrastructure as code, which is people can ask, well, should I use Terraform? Should I use ARM? Should I use language X? And I think people kind of expect to have a definitive answer. Unfortunately, there isn't one, and it's really going to depend on what it is you want to actually achieve, and what functionality you need with your infrastructure as code tooling. So, if you're coming in as a sort of, if you're starting off with Azure, then a lot of people will default to using. I say, Gregor, I see your point there. What do I prefer? Okay, well. It varies a bit as well. So I've worked my way through a number of different languages. So I started with ARM templates, as you know, and I still do a fair amount of work with ARM templates. I've done a lot of work with Terraform, particularly on my day job. We started off using Terraform, and then recently we've moved to using Pulumi. Now, if I just want to very quickly throw up some resources, get something deployed, write a very quick template, then ARM templates, particularly if it's Azure, obviously, ARM templates are probably the quickest way to do that. So if I want to do something very quickly, that's usually what I'll go for, because I don't have to worry about state files and all the complexity that brings. I can just throw some code in a file, run it and deploy it, and job done. So something quick, yeah, ARM templates, or probably Bicep in the future. But if I'm doing more complex stuff that involves a lot of resources talking to each other and a lot of dependencies and that sort of stuff, then I do prefer a stateful language. So something that has a state file where I can actually see what's being done. And yeah, ARM's got what if, and that is a benefit going forward. But the benefit of Pulumi and Terraform having that state file, particularly also to be able to do cleanup, is pretty useful. And some of the more advanced features, to be able to do loops and if statements and so on in a better way, are nice. Of those two, I think if I was going to do something today, I would probably pick Pulumi, just because doing things like loops and conditionals and stuff is so much easier when I can do it in. I tend to do it in C# or whatever language you like, but in a real programming language, compared to trying to do a for loop in Terraform. I don't know if you ever tried that, but the for syntax and the for each syntax in Terraform is relatively new, and it can be painful to try and get to do what you want it to do. Whereas, if you've been developing for a while, you know how to write a for loop in C# or Go or Python. And so, yeah, if I was doing something complex today, I'd probably pick Pulumi. Yes, I do like Bicep. Thanks. A question there, Rini, I think it is. Yes, I do like Bicep. So if I was doing something today and it wasn't production, or obviously when Bicep gets to production, I would use Bicep over ARM. I think it's a much cleaner language. I think it's much easier to read, particularly if you're going to share. If you're going to share those templates with other people. I think it's a much nicer language for that, particularly if the people you're sharing with are relatively new to infrastructure as code or to Azure. The Bicep language is easier to understand, I think. So yeah, I do think it's a big step forward. I don't think it's going to pull people away from who already invested in things like Terraform or Pulumi, but I think for people who are coming in to Azure for the first time, or people who are already using ARM, I think it'll be a big benefit. Has everybody here seen Bicep? Does anybody want to have a look at how it works? Because I can do a quick demo of Bicep if you've not seen it before. So let's quickly do that. So Bicep is a sort of layer of abstraction on top of ARM templates. And if you're familiar with an ARM template, so let's have a quick look at an ARM template here. Actually, let's go and open one up that's got some stuff in it. There we go. Yeah, okay, so this is your standard ARM template. You can see you've got your JSON, you've got your different sections, and you've got your parameters section, you've got your variables, and then you've got your resources that you're deploying. So a lot of JSON, a lot of commas and brackets and so on. So, can be quite complicated to read. Whereas with Bicep, and I think I've got this same file actually in Bicep. It's probably not the greatest example. I just start from fresh. So Bicep, one of the nice features of Bicep is that you don't need to deal with all those sections. You can put your resources wherever you want. So you can start off with some parameters, for example, and there is a new sort of param keyword. And then you give your parameter a name. So let's go with storage account name and a type. And that's it. That's all that a parameter has to look like in Bicep, which is quite a big improvement over something like this, which is this is the actual Bicep one. Over something like this, a lot more nesting, a lot more commas and quotes and so on. So we can do that, and we can do the same sort of thing. We can do variables. We can do. It's just LRS. We'll go with that. Wrong quotes. And so on. So you can declare your variables a lot more succinctly. You can add some defaults here as well if you want. Whatever you want to do there. But where it gets quite a bit nicer is when you start looking at the actual resources. So we're going to deploy a storage account, for example. You give it a name. So this is the name that I would refer to it as. And then you're going to give it the actual type and API version. And this is where I think the intelligent sense could get a little bit better. And where I think my IntelliSense is actually playing up a bit. Yeah, otherwise isn't doing it as a big as a list. Let's do that one. Yeah, so then we can fill in. Yeah, I think there is an issue with my IntelliSense, but we can. Well, I'll just do it. I'll copy and paste this one. It'll be easier. Just fit. There we go. So yeah, so this is what a resource would look like in the Bicep language. So you can see it's quite a bit simpler than what you would talk about with ARM. You've got less of the actual language pieces around it, but also they've done things like integrate the actual type and API version up here into the header, so it's not a part of the property now. You can pass your variable and property parameter name straight in, and you can just reference them directly, and you can obviously then pass in those values and so on. So it's a lot simpler to read and to work with. Yeah, and you're asking, is Bicep using native available Azure providers, or is it dependent on its own Bicep Azure end provider like Terraform? No, so the way Bicep works, and this is where it gets a bit different to everything else, is Bicep itself isn't actually deployable. What you've got here is basically my definition of what I want to deploy, but I can't deploy it like that. So there's a command line tool that you would use. So let's bring that up. Zoom in a bit. So I've got my Bicep file here, and what I would actually do is run the Bicep command line tool, and then Bicep build, and called template.bicep. So what this actually does is it compiles the Bicep template into an ARM template. So what you're actually deploying, yeah, there is always a new PowerShell available. What you're actually deploying is the ARM template. You're not deploying the Bicep file. Azure itself doesn't have any concept of Bicep in terms of it being something it understands. You run that command, it generates the ARM template, and then you deploy the ARM template. So all of the tooling that existed before for deploying ARM templates still works with all this. It's just this is an automatically generated ARM template. It's not something that you actually need to pay much attention to or actually read or care about. You just generate it, deploy it, then you can throw it away. The source of truth is your Bicep file, but you need to then compile it into that to actually release it and deploy your infrastructure. Now, there's good and there's bad. Good things, good and bad things to this. It does add that extra layer when you want to do a deployment that you have to actually compile that. Now, I wouldn't be surprised if we see things like the PowerShell command and the CLI and stuff abstract some of that away and just compile it for you when you want to run it, so you don't actually see that level. But it is an extra step. But obviously, it means that it doesn't break existing tools. It means that the ARM team, which are a fairly small team, can go and create this new language without having to go and get every team within Microsoft to go and create new providers or anything like that. Ultimately, everything is talking to the Azure API at the back end. If you look at Terraform and so on, then you would just they're just talking to the API at the back end. They're just handling a lot of that for you, whereas Bicep uses the ARM layer as in a sort of an extraction above that to deal with that. Opal, actually, you asked, is parameters handled in the same fashion? Yeah, so at the moment, you have to define your parameter files as a JSON file. There isn't a Bicep equivalent of the parameters file. So if we go ahead and do that. So we would just declare that as a normal parameters file, like you would with, so we'll just do storage account, name. Yeah, we could do that. So that would be the same. There isn't a Bicep equivalent of the same thing for this. It's still the old JSON version, because obviously this only really gets used at the point you do your deployment, when you run the new AZ resource group deployment or whatever, and you're feeding that your ARM template, and you would feed the parameter file alongside it. Maybe we'll get a Bicep version of the parameter file as well in the future. Obviously, having that syntax simplified would be fairly beneficial as well, so we might see that. But with the moment, no, it's a JSON file, and that's it. So there's a few nice features in Bicep if you're not familiar with them. Just open up another file. Where is it? Demo I did the other day. Let's do that one. So Bicep has this concept now of modules, which is something that was kind of lacking in ARM templates. So you can basically build reusable lumps of code that you can then distribute to your team members and so on and have them run that. So this here, I basically created this storage account module, which again is just creating a storage account. And you'll find a lot of my demos create storage accounts because they're really quick and easy to do. But this is just calling that this module that I've created. Now the module itself is just a plain old Bicep template. It's got parameters, it's got variables, it's got resources, and it's got some outputs. So this isn't, I don't have to declare this as a module or anything like that. But what I can do is I can basically create an interface with parameters and outputs for this thing. And then in my top level template, I can call that just by referencing that file. Now, if you've ever used ARM templates, you had this concept of nested templates that you could actually use to do something similar, but you always had to put those nested templates somewhere accessible to the Azure fabric so that you could reach those when it ran at deploy time. So not even on your machine, it needed to be in a storage account or something similar. Excuse me. With these Bicep modules, you don't need to because you can just reference them as a file that's locally on your machine. What actually happens when you compile that, I think I've got that here, yeah, is that compiles it into an ARM template again. And what it's actually doing is creating a, where are we? Yeah, it's creating a nested template. So it's kind of behind the scenes is building up a nested template for you. So it's using the same technology, but you don't really have to care about it. But it uses a nested inline template. So if you've ever worked with nested templates, you know there's two versions. There's an inline version where you basically just declare a template with inside a template. And very rarely did anyone use this because it was a bit pointless. If you wanted to use nested templates, then they wanted the benefits of modularization, you'd create a new template. But the only reason you really use it is if you needed to deploy something into a different resource group or subscription compared to the one you were actually running the file against. But they use this nested inline template here to create this ARM template. So that means that all of the data that's actually needed by Azure to deploy this module is inside the ARM template. Doesn't that you don't have to worry about deploying it to another storage account or anything like that. It's included in this. It can obviously make a fairly complicated and difficult to read ARM template, but because you're generating this automatically, it doesn't really matter. So you can make these as complex as you want really, because you're not dealing with this part. You're just dealing with a nice, simple Bicep file that's referencing that module. And then when you come to deploy it, it should run that ARM template and deploy all that for you. So the modular piece in there is quite nice. But again, none of this is going to compare to some of the modularity stuff you can do in Terraform or in Pulumi, where you can create NuGet packages or npm packages and distribute them in that way, which is obviously much cleaner. So again, this is really, I think, aimed at people who are coming to ARM templates new or have been working for them a while and want a better language. So yeah, that was a very quick run through of Bicep and how that works. Any questions on that or anything else you want to see? I'm happy to oblige. So perhaps it might be worthwhile just having a quick look at the different... Gregor, you got a question there? Yep, sure. So we can have a quick look at that. So this is, if you're getting started with an ARM template, one of the things that can be a bit daunting is how do you actually write that to deploy the resources you want. The ARM documentation, while fairly thorough, is a little bit detailed for someone who's coming new to it fresh. So if you are starting out with ARM templates, there are a few things you can actually look at to get going with that. So let's hop over to the portal and we can have a look at those. Okay, so the first thing you can do is you can come in here and you can look at your resources. Let's find an interesting resource group that's got something in it. I really need to clean up my my resource groups. Okay, let's go with this one. So you can come into the actual resource group and you can come down to the, where is it? Export template. So zoom in a little bit. So you can come here, click on export template for a resource group or a particular resource, and you can have it export you an ARM template. So you can see over here, this has created an ARM template for me that I can just copy and paste and I can use in VS Code or something like that. So let me just grab that because it's probably easier to read if you put it into VS Code straight away. So this has been generated for me from the portal. And it's a pretty reasonable place to start. But one thing you do have to bear in mind is these auto-generated ones are going to be quite verbose. So what you'll find is, for example, you've got here, all I've got in here is a VNet and a network interface, but each of those things needs a name. And so when you generate it, it's created me a parameter to specify each of those names. Now, if you've got a lot of resources, that's a lot of parameters just for names. And you'll find once you start working with ARM templates for a while, you never do that. What you tend to do is pass in sort of a prefix that's part of your naming convention. So you'll pass in that, which is designating the environments. Let's say this is West Europe Dev. That's my prefix, and then you'll append that in here with -vnet or -nic or whatever you want to use for your naming convention. But you won't pass in a name for every single resource type. You'll come up with some sort of convention or way of making that, so you don't pass in hundreds of parameters every time, because that can get tiresome. So that sort of thing is going to be a bit verbose. So you probably want to clean that up, make sure the parameters are right. You might find in here that there are some things that you in the resources that it's put in, and you might want to tweak, or you might normally not have provided. So like here, virtual network peerings, I'm not passing in any peerings. So generally in my template, if I'd written it from scratch, I wouldn't have even declared that. So I'll get rid of it. And some of these, these are the default values. So you can have them if you want to fully explain everything you're doing, but you could also clean up and make your template a bit simpler if you do that. So that's one way of getting a starter template if you want. There's also some PowerShell and CLI commands that will do that for you. Off the top of my head what they are, we can have a look in a minute. And then another resource I use quite a lot, if you've not seen it, is the resources portal. So the Resource Explorer lets you basically look through all of your resources in your subscription using this sort of tree-based view, and all it does is show you the JSON of everything. So I can go and look, pick a subscription, pick a resource group, find some resources. Yeah, let's look in the key vault section. And I can see my particular key vault, and then I can click on that and I can go look at the JSON. And that will show me the exact JSON that defines what that resource looks like now in Azure. So that you can take those, you can have a look. And often I'll just come in here to say, okay, well, I don't know how to set access policies on a key vault. So I'll come in here and it'll show me the syntax for that. And I can just put that into my template. and this is useful even if you're not doing ARM templates, even if you're writing Terraform or Pulumi or something like that. Quite often you'll come in and say, okay, well, I know I need to set the access policies, and I know the syntax, but I don't actually know what an acceptable value is for this this list of permissions. Get lists update, but there isn't a set in here, whereas there is a set down here. So I can, if I just want to get the acceptable values, I can come in here and pick those out as well, which is pretty useful. And then the other thing, obviously, is the actual docs. So you can have a look at those. There's a reference here, so you can basically get the specification for every single resource available through ARM through these documents. But again, if you're new to ARM and you don't really know what you're looking for, they might not be the best place to start. Yeah, but that's what I use. Krusty, you ask about template specs. Yeah, so this is something I've got access to. I haven't had time to look at much yet, so I've talked to the ARM team about this a bit, and it's an interesting concept. So template specs, for those who aren't familiar, I wonder if the docs are out there now. Yeah, there we go. Okay. And so, yeah, so it looks like it actually is in public preview now. So template specs are a way for you to store templates, particularly when I talked before about the nested template scenario. It allows you to store your templates actually in Azure that you can then publish and make available to your team to use them, and basically providing a better way for you to have those nested templates available for when you run, rather than just having to shove them in a storage account, which is what most people do at the moment. So in principle, I like the idea. I think it will be a nice improvement, although obviously if you then go down the route of using Bicep and using the modular function in there, potentially you might not need this. There's a couple of different ways of doing the same thing. But yeah, I like the concept. I haven't, unfortunately, had time over the last couple of months to spend much time with this. Yeah, but I do think it is a step in the right direction. We'll see how it turns out, and then once people start using it in anger. I've got the reason I haven't dived into it immediately, because obviously I've got a fair amount of processes already set up where I publish an ARM template to a storage account using a Azure DevOps pipeline. So most of that's fairly automated, and I don't need to use this at the moment because I've built ways around that. But yeah, again, if you were coming to ARM templates fresh and you needed to use a nested template, it's confusing enough figuring out how nested templates work without then having to deal with, okay, well, where do I store them and so on. So hopefully this will be an improvement on that. Any other questions, just feel free to drop them in the chat. I will be happy to pick those up. So we've talked a bit about Bicep. We've talked about getting started with ARM. We've talked a little bit about which language or which infrastructure code tooling you might use. Obviously, we've talked about the sort of big ones here. So we talked about ARM, we talked about Bicep, Terraform, Pulumi. There are a few other ones out there as well that might be of interest if you are coming to this looking for languages. So another one I believe is called... Oh, no, that's not going to help. That's just going to bring me up a pub. Is one called Farmer. So Farmer is a similar concept to ARM templates. To Bicep even. It's an abstraction on top of ARM. Now, this isn't something I have actually looked into or used very much, or not at all really, but it's just something that I've read up on and I've heard people using. It's another interesting abstraction which basically intends to reduce the amount of code you have to write. So you can see here again, this is a simplified language. It's not dissimilar to what we saw with Bicep, and you'll have seen yourself. Bicep itself doesn't look particularly dissimilar from Terraform. So I think everything, there's been a lot of inspiration taken from those sort of things. But again, this is using this as an abstraction, and then it provides this way to actually deploy resources, which is quite an interesting project. And this is all open source, being done by some people in the community. This hasn't, as far as I'm aware, not got any Microsoft involvement. So that's quite interesting. I mentioned earlier that I've been doing a fair amount of work recently with Pulumi, so might be worth just a quick intro to that as well. I think most people here are probably familiar with Terraform, but Pulumi is a relatively new one. So the idea of Pulumi is that you can actually write your infrastructure as code using real programming languages. And I see, Gregor, there you're asking about the learning curve between these things. So yeah, there can be a fair amount of difference in the learning curve for these, depending on where you're coming from. So we'll talk about that in more detail in a minute. But just quickly to summarize the Pulumi stuff. So Pulumi, so you can use real programming language, and you can use a choice of about 4 or 5 languages. So you can use .NET languages, you can use Go, Python, JavaScript or TypeScript, and I think that's it. But you can use that to create resources. So this is the example program they give you here. This is in C# because it's what I'm familiar with. But you can see it's not that dissimilar from the Terraform in that you're declaring resources. You've got a resource name, and then you've got properties. But this is all wrapped with a sort of C# wrapper. And it means I can use real programming idioms. So I can do a for loop. I can do, let's say, what's the easiest? We can just do something really dumb, but you can do, if, then I'm gonna go and create another storage account and give it a different name and so on. You can use different programming idioms in there, and this can be easier on terms of the learning curve if you're coming to this from a development angle. So one of the reasons why we picked this up at my day job is because we had an urge for a lot of developers to pick up writing some of the infrastructure code. So they're coming from a world where they're writing C# every day as part of their normal programming job, and to actually get them to then switch languages and use Terraform or ARM to then write the templates to go along with that was a difficult challenge. And whereas if we can go down this route and let them write C#, it's less friction for them to do that. So if you're coming from a development world, then this might be a bit easier. But coming to this, I'm not a developer. I can write a bit of C#, but I'm not a developer. And so coming to this from my side, doing things like this, the simple stuff was very easy. But when you start getting to some of the more complex stuff where you want to, we were creating some reusable modules and things, and you need to use some more programming idioms, some of the asynchronous pieces, some of the more complex things that I hadn't used before. The learning curve on that for me was pretty steep. So it can depend on the angle you're coming from. All of the languages, I think, they do have a bit of a learning curve at the beginning anyway for anyone coming to them. Writing ARM templates or Terraform, it doesn't. You wouldn't immediately understand it if you came into that. You're always going to have to put a bit of effort in. ARM templates potentially are a bit simpler in terms of getting going and getting up to speed because you don't have to deal with that state file piece. The state file has a lot of benefits, but if you're coming fresh into it and you want to actually just create some resources, having to figure out actually how the state file works and where to store it and getting that all set up so you don't lose the state file, that sort of thing, can be a bit of problematic. Now, both Terraform and Pulumi try to make that a bit easier using their cloud services to actually store the state. But I know a lot of people have issues using cloud service for that sort of thing, especially if you're just trying to sort of try something out. You want to figure out a better way of moving off your PowerShell scripts and doing that. Having to sign up for a cloud service and potentially get your InfoSec people to sign off on you storing data there and so on is going to be painful. So not having to deal with that and just getting straight in and deploying some resources is quite a big thing. I always find that people tend to get to the infrastructure as code concept once they've written a quick template and just deployed one resource. Nothing beyond that, but just sticking a storage account, seeing that they can change their name or change the type and it will change their resources in Azure. That tends to be when it clicks with people and they can sort of, pick it up and go from there. So, that can be a real big benefit. Seems we've got some sort of spam in the chat, which is helpful. sure how to get rid of that, giving it my first attempt on Twitch, but let's get rid of that. How do we deal with that? There we go. I've obviously got enough people in the stream to warrant some spam bots. Yeah, so if you just want to get going and you want to be able to deploy a resource and see how this whole infrastructure as code thing works, then ARM templates can be a good starting point. But if you're looking to actually then start moving forward and implementing things in your, and getting people on board and getting them to use them, at that point you want to start making a decision about which language you're going to use, because it can be quite painful to try and chop and change between things. So ideally, if you're going to start, you've done your little proof of concept, you've figured out that infrastructure as code is the way to do, and then you're ready to go. You want to start making a decision about which platform, which language you want to use, so that when everyone starts getting up to speed, you can stick with that rather than having to chop and change later. It's not the most fun thing in the world trying to import state into Terraform once you've built it in ARM templates and those sort of things. Okay. Right, Gregor, you were asking about testing. So that's an interesting concept. It's one of the nice things you can do once you move into using infrastructure as code. Because you've got these IAC files, you can test them because they're really just code. So let me bring up some examples of how you might do that. Okay, so here's some examples from another talk I do just about ARM templates in general. So this is how we can test ARM templates. So we've got a few things here. So ARM templates at the base they're just JSON files. So if you can manipulate them with anything that's going to allow you to manipulate JSON. So one of the most common ways to test ARM templates is using something called Pester. So if you're not familiar with that, Pester is basically a testing framework written in PowerShell. It's been around for quite a long time now. You will find it's actually already installed on most of your PCs, but that's quite an old version. So if you do want to use that, you'll probably want to upgrade. But yeah, Pester allows you to basically write test suites to test anything using PowerShell. And so I've got some very basic tests here that do some testing of my ARM template. And these ones are fairly rudimentary. They're a demo for just people looking to get started with testing, and it's doing a few things. So this is the Pester language, and there's not that much to it. It's all PowerShell, but they add some sort of language elements that allow you to do some things. So the first thing is these describe and context blocks. These allow you to just basically group your tests together. That's really what they are. There's a few more things you can do with them, but effectively they're just buckets. And you can group those up, and then inside them you can have your tests. So this it command is what actually is your test, and it allows you to sort of say it, and there's some text that describes what your test is doing. So this one, it has a JSON template. So all I'm doing here is to check that the folder I'm actually running my tests in actually has a file in it called Azure deploy.json. And then Pester has a load of comparison things that you can do to actually execute your tests and have your what's the word for them? I can't remember now. But this will actually test to see what it is you're testing against is true or false. So in this case, I'm passing it to the should exist command. So this says this file should exist in this path, and if it doesn't, the test will fail. And we do that a couple of times with some other files, and then we do some things a bit more complicated. So the next one we want to do, this actually combines two things in one. So the first thing is we want to check that our template file has actually got valid JSON in it. So if I've missed off a comma or a semicolon or something, I want to pick that up before I try and run it. It'll save me some time. So the first thing I'm doing is actually running this convert from JSON command. This converts my template into JSON. If it's not valid JSON, it will throw an error. And that will tell me that that's not valid JSON. I'm combining that, and I could have done this in 2 separate tests, to be honest, to make it clearer to read. Probably better way to do it. But what I'm also doing is I'm reading that JSON in, and I'm comparing it to check that the JSON contains all these 6 sections. These are the sections you'd expect to find in an ARM template. And so I'm testing to make sure they're in there. And so I pass that through to get the template properties. If this convert from JSON fails, the template properties will be null. So it will fail this test that it's saying that this should be expected properties. And if it's not null, then it's going to compare the contents of this template properties to the contents of expected properties to see if they match. And I had to throw in a sort object there to make sure they're in the right order, otherwise it will fail even if they're in the right values but in the wrong order. So we're testing that. And then we do a similar test here, but instead of looking for the sections, we're actually looking for the types of resources we've got in the template. And this sort of thing might seem a little bit odd if you're coming from an IT pro bit of world, or even a developer to some extent. Generally, when you're writing code and you want to write an ARM template or whatever, you try and make it as reusable as possible. And you try and make it so that it's generic and you can pass in parameters and you can use it more often than not. Whereas when you write tests, and if you are a developer coming where you've written unit tests and so on, you generally are going to try and make them a bit more specific to what you're actually looking for. So it would be very difficult to write a test that just checked whether my template had the right types of resources in it without knowing what the resources I'm looking for. Now you could try and parameterize that and pass it into my test or something like that, but that's going to be pretty painful. So this test here is written specifically for my template, where I'm expecting there to be a storage account, an automation account, a virtual network, and so on. And again, I pass that through, compare those two together, and we check that. And then the last test here is looking at the actual template as a whole. So when you run a template to actually deploy it, and you run the new AZ resource group deployment command, before it actually deploys the resources, what it actually does is it runs some pre-flight testing to check that the template is valid before it tries to run it. There's a whole load of things it does in there. There is a version of that command, which is the test AZ resource group deployment, which just runs that test piece and doesn't actually try and actually deploy the template. It just runs those tests. So the last test we do is to actually feed that to that command and run the test command, and then check that it's null or empty. So that command returns basically empty as long as there were no errors. If there were problems, it will return the error, and so we can test that. Now, there's a slight complication here, because the test AZ resource group deployment command expects you to have a resource group that you're deploying against. Even though it's not actually going to deploy any resources, it still has to be there, which is slightly annoying. So we use some of the functionality of Pester here to run this before all command, which creates that resource group. And then we use the after all command to actually delete the resource group when we're done. So it cleans up that resource, so that only exists for the duration of the test, and that's all we need. And there's a few functionalities in Pester that will allow you to do things like that. Like you can have Pester create a fake drive for you if you need to store some files locally as part of your tests. It will create that drive for you, and then throw it away when you're done, and so on. You can do a few of those. So if we bring up the command line, and shouldn't put spaces in file paths. And there's a command in here, I think, somewhere. There we go. So we can run our tests. It's just a PowerShell file, so you can just run it. And this will go ahead and run our tests through, and it will give us a nice visual representation of the tests to see if they passed or failed. So you can see most of them passed, but I've got a missing metadata file. That was on purpose. And the rest of them are going to pass. This is taking a little bit longer to finish because it's got to delete that resource group for me. But that's some very simple tests. And you can obviously make that as complicated or as simple as you want. You could test, every single resource. You could also do some tests to actually deploy the resources and then test them once they've been deployed. You could do things like that. So you can make them as complicated as you want. if you were just getting started with testing, one thing I'd recommend you have a look at is the ARM Template Toolkit, if you're not familiar with this. The GitHub one. So the ARM TTK, as it's referred to, is a testing toolkit that Microsoft have created. It's basically designed to test your ARM templates against best practice. So there's a whole load of tests in there pre-written that look at your ARM template and will tell you if you've written it in a way that sort of complies with best practice. So if we run that, I think I should be able to do it with a command from in here. So it's just a PowerShell library. You can install it with the install module command, and it gives you this test AZ template command. He says not having imported it probably. Yeah, so where is it? I've got multiple copies of this installed, so let me just find the right one. Interesting. There we go. Yeah, so if we run that, and let's just run it on here. So you can do it in different formats. Yeah, so this is run the test, and this is a pretty awful ARM template for this, so it's failing quite a lot of them. But it's going to give you a load of tests that it's going to run to check things like, so, admin username should not be literal. Well, I've passed that one. But then I've got another one here, API versions should be recent. So this is checking to see that all the API versions I use in each of my models are fairly recent. I think they're all newer than 6 months or something like that. So I've failed a lot of these on all these resources because this is a pretty old template. And I'm doing some depends on with start with concatenate, which is a bad idea. I've got hard-coded URIs and all sorts of things. There's all sorts of things wrong with this template. But I didn't have to write any of those tests. They were ready to use for me by, Microsoft done that for me. So it's something that you could very easily quickly throw against your templates, and you could even then start integrating those into things like pipelines and automated deployments, which are kind of the next step you look at when you're trying to do this CI/CD approach, and you want to take your ARM templates and use them as part of a deployment. Why not throw some tests in beforehand to make sure that things are going to work before you try and deploy them? Any other questions we can have a look at? We've got a little bit of time left. So I'm quite happy to answer any other questions about anything related to infrastructure as code. It doesn't need to be ARM templates. If you want to talk about Terraform or Pulumi or any other language you're interested in, quite happy to discuss those. No immediate questions. Okay, so what else have we got? We could have a quick look at. Okay, Gregory asking what best code completion in terms of within VS Code. Yeah, so it's an interesting one. So I use a variety of different tools for the languages. So you see, I use VS Code for ARM templates and Bicep. I think the Bicep VS Code plugin does a better job in terms of IntelliSense and code completion and stuff inside VS Code than the ARM template one does. The ARM template one is still pretty good. But yeah, it does. I think it does a better job. The ARM template one has got a pretty extensive set of snippets in there, which I'll just highlight because I wrote those. So they are useful if you want to actually get some full code snippets. I'm sure the Bicep ones will come up to speed on those at some point as well. In terms of the other languages, at the moment I don't use VS Code for Terraform. I use this tool called PyCharm, which is a resharper tool. Just because the Terraform extension for VS Code was pretty awful. It broke when it moved to Terraform 12. Now recently, HashiCorp have taken ownership of that extension. I know they've done some work to make it better, so I haven't looked at it recently, to be fair. But yeah, I used to move to using PyCharm, which is a Python editor, but it has a really good Terraform plugin which does a lot of the IntelliSense and stuff for you. So I use that for this, and it does a lot of code completion and everything. There is a free version of this. Unfortunately, I have a paid for license because ReSharper were kind enough to give paid licenses to MVPs, but there is a free version of this as well. And then for things like Pulumi, you can do it in VS Code, but I tend to use Visual Studio for that because obviously with writing C# has a lot of the built-in stuff. And I'm lucky enough, again, to get a license through the MVP program or at work. They pay for that. But again, you could use VS Code for that as well. I'll come back, Opal, to the Ansible question in a minute as well. I'll just finish up with the DT in the cloud when you're asking about extensions for VS Code. Yeah, not massive amounts anymore. So what have I got installed here? Some .NET stuff and some Azure stuff. Most of it's not particularly related to infrastructure as code. So it's mainly the ARM template. Wherever it is, there is your Resource Manager extension one and the Bicep one for that. There is this ARM template viewer one to generate diagrams. That can be useful sometimes. That's interesting. There's some of these Azure ones which allow you to actually then go and deploy those resources or fiddle with them in VS Code, which can be quite useful, especially if you're doing something like logic apps or things like that. What else? Most of those are Azure pipelines, some C# stuff, which is not terribly interesting. Yeah, the Terraform one in there, say, is probably been improved now. I should probably go and have a look at that. I use Prettier to do code formatting, which can be quite useful just to format your JSON. Yeah, and that's probably about it in terms of actual infrastructure as code. I don't use massive ones. I used to have my snippets one, but that's gone now. That's been integrated into the ARM template one. So yeah, only a few of those. So Opal, your question on Ansible. So I tend to personally see a bit of a line between infrastructure as code and configuration as code, which classically is where Ansible has been, and Puppet and Chef and those ones. Now I know Ansible can do a lot more than that nowadays, and you might use it as a means of deploying Azure resources, but generally there's been a line between those. So I've used the infrastructure as code tools to deploy, say, a virtual machine, and then I will use the configuration as code to configure that virtual machine, which might be Ansible or Puppet or Chef or whatever. But usually there's a handoff between those two to try and to make sure that once your VM's deployed, that it's automatically onboarded into your configuration management tool and gets all the things deployed to it. So that might be something like you installing one of the Azure extensions that allows you to register your machine with Ansible or Puppet and have it set up with that. And then once it gets registered, the Ansible server will pick up that machine is registered and it'll do all the logic it needs to do to actually determine, I'm going to install this stuff on that. So yeah, I see them as two separate things that generally we find a way to join them together, rather than being one tool for everything. And I know you can deploy Azure resources in some ways with Ansible. I haven't actually tried the Ansible way. I know you can do it with Puppet. We did some things with that, but it's a bit of a hacky way with Puppet in terms of having it basically. You create a VM that acts and pretends like its configuration is the Azure configuration, and it deploys things. I tend to use the tool for what it's built best for, rather than trying to hack in some other bits and pieces. Yeah, and you're asking, added to IC, let's say I have good control on the Azure resource side of it using Terraform. What is the best way to have application configuration as code? Okay, yeah. So that's kind of an extension of that question. So there are a few different ways you can do that. Obviously, there are the commercial tools you can buy, like Ansible, Puppet, Chef, Salt is probably another one, that you can do your configuration as code in that manner, and then you can link the two up, like I said. So that's one way of doing it. Another way is you can look at running some actual configuration when you deploy your resources. So if you're not too fussed about sort of the centralized management, which is what a lot of those configuration management tools give you, is a way to see all of your machines in there and see the status of them all and see which is compliant and whatever, and roll out changes to all of them. If you're not too fussed about that, then there are things you can run as part of your ARM template. So you can run the custom script extension or the PowerShell DSC, the desired state extension, as part of your ARM template, and you can then have that call and run a PowerShell script or a CLI script or some DSC to configure your VM at the time you deploy it. And that can give you a very quick and easy way to actually configure those VMs. Now, there's no centralized management of that. You're not going to get the status of that reported to your server. If you need to update the infrastructure on that machine, then you're going to have to find a way to run that script again, or update the script and so on. So it's not as nice, but it's certainly a lot cheaper, and you can do that. There is another sort of halfway house as well, which is you can use PowerShell desired state with Azure Automation. And so Azure Automation has the ability to act as a PowerShell desired state server. So you can have the machines report into that, and you can have the configuration pushed out from there. There is a cost to that, but it tends to be cheaper than the full-blown configuration as code tools. But it does have some downsides. It's not the most powerful configuration as code tool in the world, and to be honest, I've not seen a massive amount of updates on it in the last year or two. But it is one way to do that. You've also got the ability to use cloud config as well. So you can have when you deploy a VM, particularly a Linux one. I'm not sure if the Windows one supports it or not. But you can have them use a cloud config file, which basically is a way of defining the configuration for that machine as well. So there's a few different ways you can actually do that. Does that answer the question, or was there any of those you wanted to get into more detail on how they work? So configuration as code is a whole another topic, which can get very complex, and it's an interesting one to be talking about today, because a lot of the configuration as code providers obviously were very focused on configuring VMs or machines. With a lot of people now moving down the container route, or the microservices and the functions and that sort of thing, those configuration as code tools are losing their sort of market share because of some of that. And so it's interesting to see what some of those are doing to try and sort of step into other places, and that's why you do see a bit of the blurring of the lines or between those tools when they start trying to go into other areas. It's going to be interesting to see how they evolve over the next few years and see how many of them are still around. Really, you asked, do you prefer deploying resources using PowerShell, CLI, or via C#? So in terms of actually running the deployment, to actually create the resources, most of the stuff I do from either PowerShell or CLI nowadays. Even the Pulumi stuff, if you create it using C#, when you actually run the deployment, you still use a command line tool. Although there are some new stuff coming that will change that. I tend to alternate, or not even alternate, but I use a mixture of PowerShell and CLI in what I'm doing. It tends to be a variation on whether what I'm trying to do and where I'm running it, whether I'm running it on a Windows or a Linux machine. I know you can run PowerShell on both, but I tend to use CLI more often on Linux for some reason. And yeah, it's not uncommon to find there are some resources that only work with CLI. And particularly some of the preview stuff tends to be some of it CLI only. I don't really like that. I think Microsoft should be releasing, when they release a resource, it should work with the PowerShell, ARM templates, and CLI at the same time. I think they should really have a requirement to make that work on all three of those. Yeah, but that's the way it is sometimes. It's a bit annoying, and I think a lot of us have raised this with Microsoft in the past that it's not great. So hopefully that will improve. But I tend to use what will work at the time. Yeah, and the custom script extension and DSC to some extent can be a bit painful, because obviously you've got to run through the whole deployment process and do all that before you can test they actually work. And if something's not working, you have to get onto the VM usually and go look at the logs. The whole development process for those can be pretty painful. You can do things where you basically write them and test them on the machine manually and then deploy them, but even then it causes problems. And it's not uncommon to see a problem occur that was fine the last time you ran it, and it doesn't work now. I've certainly had my fair share of those. So yeah, I agree. Those things aren't always the best experience, but they're quick and easy and cheap. Yes, I see what you were saying there, really, about having to write an Azure function. Yeah, I've not had the pleasure of working with the Partner Center stuff much, but I think your comment there sums up a lot of what other people have said, is that it does lack some features, and yeah, you're having to write an Azure function to deal with some of that, which is not very pleasant. Gregor, any plans for a Pulumi or Terraform masterclass? Yeah, so that's an interesting one. So I did ask a question a few weeks ago about whether people would be interested in a Bicep masterclass, and I think it's got some pretty positive ones of that. I'd certainly be happy to do ones in Terraform and or Pulumi. Obviously, I've got limited time, so I'd have to pick one. I don't know what people's preference would be on some of those, as to what order they're done. The Terraform and Pulumi ones are a little bit more difficult, because obviously there's a much wider area you can cover in that. I probably would have to make it more of an Azure on Terraform and an Azure on Pulumi masterclass, rather than trying to cover AWS and GCP and all the other things as well. But yeah, I could certainly look at doing that if I can find the time. Yeah, and you're saying, if you're blank more or less Ansible, Chef, Puppet, where would you start? Yeah, okay, so that's a interesting one. This is a topic I looked at a while back when we were considering these tools for this, for internal use. It's a very interesting question, and it's very dependent on what your experience is and what you want to use. So Chef was one we looked at and discounted early, because from what I could gather, a lot of Chef required you to be fairly familiar with Ruby. A lot of the stuff was based on Ruby, even if it was even the sort of declarations. You didn't have to know a lot of Ruby, but it involved some Ruby, and I'm not familiar with Ruby. Neither were a lot of other people I was working with, so that one was sort of out the window. Ansible and Puppet were both interesting ones. Ansible is quite popular, and it's obviously now owned by Red Hat, owned by IBM, I guess. But one of the good and bad points with Ansible is that it was, at the time we looked at it, and it may have changed recently, is that it's an agentless based tool. So you ran your Ansible server, or even just ran your scripts manually, and they talk to the host they're going to deploy to using either WinRM or SSH on Linux. And so you don't have to install an agent, which can be quite a benefit, but it can also be a bit of a pain if you've got multiple different environments on different virtual networks that aren't connected to each other, and you're going to have problems of opening up ports to your Ansible servers to be able to talk to them directly. Where the agent-based approach that Puppet's got, where you can install an agent on the machine and then have it talk back to all the traffic's outbound to your Puppet server, can make the security approach on that a bit easier, because you're only having to deal with inbound traffic to your actual Puppet server rather than the other way around. But yeah, I know, Puppet itself can be quite complicated and have quite a steep learning curve as well. It's also based on some Ruby. You don't need to use Ruby in day-to-day operations, but if you want to do any more complex sort of under the hood stuff, then particularly writing modules for it, you do need to know a bit of Ruby. So that can be a complication as well. Having spoken with quite a lot of people, I think people liked Ansible because it was simpler and it was easy to get going with. But you've got that security concern possibly, I can't give you a definite answer, to be honest. I know a lot of people I've talked to really did like Ansible and liked its lack of complexity compared to Puppet. Puppet, from what people I spoke to, can be quite a steep learning curve. So yeah, can't really give you a definite answer, but but that's my view on it anyway. Okay. I was going to roughly do this for an hour or so. So we're past the hour now. I'm quite happy to answer any more questions if anyone's got any more they want to get in before we finish, or if there's no more questions, we'll probably call it a night and wrap it up. But if people enjoyed this, I'd certainly like to, let me know. And if you'd like to see this been done again in the future, I'd be more than happy to do that. Maybe we could focus around specific topics or some specific areas or anything. But yeah, I'd be more than happy to do a few more live events if people are interested. What's my least favourite resource to work with in ARM? Ooh. Front door. That's what I'm going to say is front door, because it's the way they've designed the API for front door is that it's one big resource. So I don't know if you've ever used front door. Then it's you create a front door instance, and then you have various front ends, back ends, and routing rules in there. Not dissimilar to something like API management or app gateway, but they've designed it so that all of those different front ends and back ends and so on are inside that one big resource. So if you look at APIM, there are separate resources for APIs and for back ends and things. So if you just want to add a new front end for APIM, you can just create another item. Whereas for front door, you have to basically add it into the existing resource, which means if you ever want to do any sort of programmatic updating of the templates, or even if you just need to edit manually and you've got lots and lots of front ends, you're now going to go and dive through this resource to find the bit you need to add in. So I really wish they'd split that up into a separate pieces rather than one big resource, because it's really hard to manage. And to be honest, in some of the automation I did with front door, I ended up not using templating and doing some PowerShell commands. It's been a pain, and it's not even just ARM template, because that's the way the API is set up. It's the same in Terraform and Pulumi as well. So hopefully that's something they'll look at in the future. Hey Stuart, good to see you as well. Yeah, Data Factory is an interesting one as well. Unfortunately, I haven't had to do an awful lot with that on templates, but yeah, that has an awful lot of different components, things you've got to hook up together. Yeah, that can be pretty painful as well. That's a good candidate. Yeah, front door is an interesting beast. It's got a lot of potential, and it's certainly a lot nicer tool to use in terms of providing a sort of a WAF and other things than something like App Gateway, because you don't need to deploy it to a VNet and so on. But it can be, some of the features obviously are fairly new, and some of it's missing. So yeah, it depends what you're trying to do with it. I would expect it to improve over the future, but yeah, I certainly agree it's missing some features that would be nice. Okay, well, it's certainly great that everyone enjoyed this and that you want to do it again. So I'll certainly look at doing some more of these sessions. And yeah, I think we'll call it a day there. Thanks very much for attending, and I hope you all have a great Christmas and enjoy the rest of the festive calendar. Thanks very much.